Hi everyone, today's video is a critical look at proportional relationships, and you can see right in the title that we're going to do some work with proportions today. And so let's take a look at number 1 here. It says Paul walks for 4 miles in 50 minutes. How many miles can Paul walk in 212.5 minutes? Well, without doing much math, we could fill in this little table here and just kind of map out how far he can walk in a certain amount of time. So let's go ahead and fill in this table. What they give us in the problem is 50 minutes, so I'm going to just put a 50 right in here, and he can walk 4 miles in that amount of time. Alright, so I'm going to put that in black, and I'm going to switch over to blue here because this is what I'm going to assume off of that. Okay, so if he can walk 4 miles in 50 minutes, well, then I could double that, and I could say, well, he could walk 100 minutes, and that would double this as well. He could walk 8 miles. Okay, and then I could go up by, say, another 50. Alright, and I could say 150 minutes, and that would do the same thing over here to add 12. So I could say, well, he could walk 12 miles. Alright, and then I could go up by another 50 and put a 200 here, and well, I would say, well, I'd go up by another 4, and that would be 16 miles. And actually, I'm going to add one more here, and I'm going to say, well, I could go 250 minutes, and that would go 20 miles. Well, what I'm after is 212.5 minutes. So I know it's going to be somewhere in between these two values right here. Okay? But I want to get a little more precise here. I know it's going to be in between 16 and 20 miles that he's going to be able to walk, but I want to be a little more precise. Alright? So we're going to go back to something that we did last year. Alright? And we're going to set up a proportion. And I'm going to use this original set of values that they gave me, and I'm going to set up a ratio and set it equal to another ratio, and of course that's what a proportion is. So I'm going to do that right over here. I'm going to say, well, in 50 minutes he walked 4 miles, and usually when you talk about like a rate, like how far you're walking for so many minutes, you usually put the time on the bottom. So I'm going to put he walked 4 miles, so I'm going to put 4 miles up here, and it took him 50 minutes. Okay, so I'm going to put 50 minutes down there, and I'm going to set that equal to, and I'm just going to match up what I know and what I don't know. I want to know, well, how far is he going to go in 212.5 minutes? So I'm going to put 212.5 right there, and notice I have minutes on the bottom here in the denominator, and I have minutes on the bottom in the denominator here. And what I don't know is how many miles that's going to match up to. So what I've done is I've set myself a proportion that will allow me to calculate how many miles he's gone in 212.5 minutes. Alright, so I'm going to cross multiply here, and 50 times x gives me 50x. And for this other one, I think I'm going to have to bring up my calculator here. So let me get the calculator on board here, and I'm going to take 4 times 212.5, and I'm going to get 850. Okay, so that's going to equal 850. Alrighty, and then of course I'm going to solve this by dividing by 50 on both sides. And let's see, bring up my calculator again. I'm going to take 850 and divide by 50, and that comes out real nice. That comes out to be 17. So, and that tells me that x equals 17, and what I'm looking for is the number of miles that he can walk in that 212.5 minutes. Okay, so I put a little box around there, and in fact, if you go over here, we said that it was going to be in between the 16 and the 20. So there you go. He can walk 17 miles in that 212.5 minutes. Alright, here is exercise number 2, and it's pretty similar to the one that we just did. Steve rode his bike for 45 minutes and traveled a total of 6.3 miles. So I'm going to go ahead and fill that in. We're going to put 45 minutes in here, and he went a total of 6.3 miles, so we're going to put that in right there. And it said how many miles can he travel in 1,000 minutes? Okay, well, again, I could do a similar thing, but here's the problem. If I double this, I go to 90 minutes, well, that's going to double this, and that's going to be 12.6 miles. Alright, and if I put another 45, or you know what, even if I double this, what if I go to 180? Well, that's going to double this again, and that's going to be 25.2. Alright, and if I can double this again, that'd be 360, and that's going to be 50.4 miles over here. And as you can see, when I want to do something that's, you know, much bigger than what I'm originally given, it's going to take me a while. I'm going to have to double it again, and you know, I'll write these in here, but you don't need to. That's 720, and then if I double it again, well, that's what, 1440, okay, 1,440 minutes, and that's a pretty wide gap there. Alright, I want 1,000 minutes, and well, that's going to be somewhere in between these two, and I'm going to get a matching distance over here, and again, it's going to be somewhere in between these two, and that's going to be a pretty big gap. So again, I would do a proportion. Alright, so let's set up a proportion just like we did before, and I'm going to put my time on the bottom in the denominator just like I did before. So that's the original information that they gave me, and I'm going to match up. Well, I want to know in 1,000 minutes, okay, how many miles I can go. So that's going to be x. Alright, and again, I'm going to cross multiply, so 45x equals, well, 6.3 times 1,000. That's going to move that decimal over 3 places, so I'm going to get 6,300 right there. And then I'm going to divide by 45, and for that I'm going to get the old calculator out here. Let's see, 6,300 divided by 45, and I'm going to get 140. Okay, so that is 140 miles that he can go. Alright. Alright, now this one is exercise 3. This looks very similar. However, we're going to take a little closer look at this. So let's do this one. Billy Bob is walking from his farm to town. The total distance traveled is 1.2 miles. And so Billy Bob took 25 minutes to make that trip. Alright, so we want to know, well, how many miles did Billy Bob walk in the first 10 minutes? Alright, well, again, we could do a little ratio here, and we could say, well, Billy Bob went 1.2 miles. So I'm going to put 1.2 over 25 minutes, just like we did before. And I'm going to make a little proportion that is going to relate that to the first 10 minutes. Okay, and what I don't know, again, is, well, how far did he go in that first 10 minutes? So I'm going to put in my x up there. And again, I'm going to cross multiply, so 25x equals, now if I take 1.2 times 10, that just simply moves the decimal over 1 place to the right, so I get 12. And I'm going to divide by 25 on both sides, just like I did before. And let's see, I'm going to bring up the calculator, although I know it's going to be really close to 0.5 here, so I'm going to go 12 divided by 25, and I get, okay, 0.48. So he's going to go 0.48 miles in that first 10 minutes. We think, alright? Because if you bring up part B says, are you sure of your answer? Now remember, for part A, we got 0.48 miles. Alright? And part B, though, they give us a little more information. It says, what if you were told that Billy Bob stopped at his friend Lee's house on the way? And what if he then met up with his friend Tyrone after leaving Lee's house and walked with him for 3 miles. Do you think that he walked at a constant speed throughout the entire trip? Probably not. Alright? This is a little more detailed table about his walk. Here's 0 through 25 minutes, and here's the distance in miles. This would be from his house that he walked at each one of these minutes. So obviously at 0 minutes, he's walked 0 miles. That's when he's starting out. So at 7 minutes, he walked 0.4 miles. But look at here, at 10 minutes, he also walked 0.4 miles. So that tells me from 7 minutes to 10 minutes, he must have stopped, because his distance isn't changing, right? So that must be when he stopped at Lee's house. All right, they said stopped at Lee's house. Okay, so I'm just going to put stopped at Lee's right here. All right, and then after 10 minutes, at 12 minutes, well, now he's 0.7 miles from his house. So that must have been right after 10 minutes. That must be when he picked up and left. But then he met his friend Tyrone, and Tyrone probably walks at a different speed than Billy Bob does. Alright, so then at 16 minutes he's at 0.9, and at 25 minutes he's at 1.2. So there may be in here a different rate. Okay, he's traveling at a different rate possibly from when he left his house originally. And then once he walks for 3 miles, so that may be somewhere in here. It might be from 0.4 to 0.7, because that's a difference of 0.3 miles. All right, and I want to add in a decimal right there. That's 0.3 miles. All right, so there's probably a different rate going on from here to here and from here to here, because after that he walks alone, and you know, people walk at different speeds. So what I have here, so we cannot assume that someone walks at a constant rate for the same you know, over the whole walk there. All right. So given this table, how far did Billy Bob walk in the first 10 minutes? Well, this was our answer from part A. Well, in the first 10 minutes, if we look at that chart, well, that meant he only went 0.4 miles. Okay, so it depends on the information that you're given as to whether you can really answer the problem. Okay, now most of the problems that we have, we're going to assume that I'm not going to assume, they're actually going to tell us that people are walking or moving or doing whatever at a constant rate. Okay, but I just wanted to point that out, is you really can't assume, if you're not told that they're moving or walking or driving or flying or whatever at a constant rate, you really can't assume that. Okay? Alright, now when you are dealing with a constant speed, this formula comes really in handy. Okay, and the D here stands for distance. That makes kind of a little sense there. And T stands for time. The one thing you have to be careful of, are you talking in minutes or seconds or hours or years, etc. And this big C, we give it a capital letter C because that's gonna stand for a constant speed. Usually when things stand for a constant, you capitalize them. All right. So we're going to try to use this formula to answer the next exercise here. All right. So part A says Andrew went for a jog. Now notice right here it says he jogged at a constant rate. Okay, that's important, because as soon as they tell us that, that means we can use this formula right up here. Okay, and he says he went for 9.5 miles, so there's my distance. I'm just going to put a little D right there. And it took him 90 minutes. Well, there's my time. There's my T. Alright, so what is this constant speed? Well, just like any other formula, if they give you all the parts except for, you know, what you're looking for, you just plug in the numbers. Alright, so let's plug in to D equals, or D over T, sorry, equals C. Let's plug in the numbers here. So for D it's 9.5, and for T it's 90 minutes. And they want to know what our constant speed is. So let's just divide 9.5 by 90. Okay, divide by 90. So that would be 0.105, and you see these 5 repeats. So I'm just going to round it to the nearest tenth here. That's going to be 0.1. And let's make sure we put in the units. The units they gave us was miles for distance and minutes for time. Alright, so this is going to be 0.1 miles per minute because I divided the two and got 0.1. Alright, now here's part B, and all they want us to do for part B, and I copied over what we had for part A right here, and so this is our final answer down here for part A. It says if X represents the time that Andrew can jog and Y represents the distance that he goes, create a two-variable equation using the speed from above, which means part A, to describe the situation. Okay, so here's what I'm going to do. I want to create an equation that I can use to predict whenever, I want, like how far he's going to jog in so many minutes. Alright? So here's what I'm going to do. I'm going to take this equation, and it says X represents the time. So instead of a T, I'm going to put an X in there. Alright? And Y represents the distance that he goes. So instead of a D, I'm going to draw myself a Y. Alright? And the C is just going to stay the same. Oh, actually though, you know what I could do is instead of having this C here, down here it says C equals 0.1. So why don't I just take that C right out of here, and instead of having another variable in here, I could put in 0.1. Alright? So create a two-variable equation. Oh look, there's two variables there to describe the situation, and usually when we have an equation you want to solve that equation for Y. So I'm going to solve this for Y. Well, how do I get Y all by itself? Well, this right now is dividing by X. Alright, now I'm going to change over to another color here to show what I do here. This is right now dividing by X. So I'm going to multiply both those sides of this equation by X. Alright, I gotta finish my parentheses over there. And what's going to happen is these X's over here are going to cancel out and leave me with Y on that side. And over here I'm just going to get 0.1 times X. And there's my equation. It's got two variables and it's solved for Y. So that wasn't too hard. Now for part C, we're going to use this equation. So I'm going to turn on part C. And the equation that I got was 0.1 X. And it says part C, use the equation you created to fill in the following table. Well, this is just what the X values are going to be. And this is just going to be what the Y values come out to be. And right in the middle here, I'm going to write in my equation. Y equals 0.1 X. So that means when X is 15, I'm just going to plug in a 15 wherever I see an X. And then I'm just going to do the math. 0.1 times 15. Oh, we better get our calculator out here. I'll move that over there. And I go 0.1 times 15. Oh, and I get 1.5. So over here, oops, there you go, 1.5. Okay, I can even put it right in here too. 1.5. Alrighty, and I'm going to do the same thing for each one of these values of X. This is going to be 0.1 times 30. And again, if I do the math, I should get 3.0. Let's check that really quick. 0.1 times 30 equals 3.0. Yep. Okay, so that's 3. And I might as well go ahead and put the 3.0 just so I have the same number of decimal places here. And I'm going to do that. I'm not going to do each one of these step by step. I'm just going to go ahead and fill the rest of those in for you. So there you have all the answers. I went ahead and I filled in all the values for X that they were giving me and calculated all the values for Y. So that means if he ran for 200 minutes, he could go for 20 miles. Alright, and if he went for 125 minutes, he could go 12.5 miles. And again, this is assuming a constant rate. Alright, so there you have it. We've taken a problem, turned it into an equation, a working equation, and now we can predict how far he's going to go at a certain amount of time. Alright, so there you have it. Thanks for watching, and we'll see you tomorrow.